So in this video, we are going to find an equation and put it in point-slope form, and then we're going to convert it to slope-intercept form from two ordered pairs. So that's our goal today, and so let's go ahead and take a look at what we would do if asked to do those things in that particular order. So first of all, notice example 1, it has two ordered pairs. Do remember that this is just your x and y value, and this is the second point on the line. That's an x and y value. So the first thing that you want to do when asked to do something like this is you want to go ahead and use your slope formula, where we're going to take the y2 value and minus the y1 value from it, and then x2 minus x1, and divide it. So I'm going to go ahead and just put an equal sign here to kind of carry this on. The only thing is I'm simply going to put parentheses in place of y2 and y1, and so on, because we're going to put numbers in there that represent those particular variables. So what I recommend doing is when you're doing this problem yourself, go ahead and set up this proportion here. Go ahead and set up this formula. Now I'm going to go over here. I'm going to call this first ordered pair, and it doesn't matter which one you call your first ordered pair, but since I read from left to right, I'm just going to say the one on the left is first. And this will be my x1 value, and this will be my y1 value. This is going to be my x2 value, and this will be my y2 value. So that way you can see where I'm getting the numbers from to substitute in to use this formula. Now I'm going to start with getting that y2 value. I'm going to circle it. y2 is this 8 right here. So I'm going to write 8. And then I'm going to get my y1 value. I'm going to circle it. Notice I did keep the sign with it. It happens to be negative, so I am going to put a negative 4 inside of the parentheses, because we're replacing the variable with the value that it's equal to. Now I'm going to go ahead and do my x2 value. So here's x2, and it's positive 2, so I'll put a 2 in there. And then I'm going to go ahead and get my x1 value. My x1 value happens to be negative 2, so I'm going to write that value in its place. So instead of x1, right, I just go ahead and put negative 2. Now I'm going to go ahead and put this in a calculator, and it's going to tell me what slope is, what m is equal to. And I'll write that down here, and we're going to use that when we try to set up our point-slope formula, and when we go ahead and convert that to slope-intercept. So let me get my calculator. Now I like to put it in just how it looks. And notice this is a fraction bar, right, because division is occurring. So I'm going to go ahead and hit alpha y equals, and then enter to get that fraction bar. I'm going to go ahead and put parenthesis and positive 8, close parenthesis, minus, and when I say minus, I'm talking about this minus button right underneath the multiplication button, not the negative, but minus. And then I'm going to put a parenthesis, and now since this is a negative 4, I'm going to go ahead and use my negative button under the 3 for the 4. So negative and then 4, close parenthesis. There is a difference between a negative sign and a minus sign, so just make sure you're using the right one. The minus goes in between two numbers, and the negative is used when you're putting a number in a parenthesis. So I'm going to go ahead and put my next value, 2. So I got parenthesis 2, close parenthesis, minus, because there's a minus right there, and then in parentheses, negative 2. I'm going to hit enter, and notice it gives me 3. So I'm going to write that down. So my slope is 3. That's my first step to getting this in point-slope form. So let's go ahead and go to step 2. Step 2 is we want to go ahead and put these values in point-slope form. Now, there's two ways you can do this. You can use either ordered pair, but what I recommend is I always just typically will use the ordered pair that has positive numbers, right? Because it's easier to deal with positive numbers. But let's say that you didn't use the one with positive numbers and you wanted to make it a little bit more difficult on yourself. You can use the one with negative numbers. So I'm going to do the negative just to prove a point, to show you that there is some distributive property that would have to occur when we do that, and we'll have some sign changes. So right now I'm going to rewrite what you see here, but we're going to be substituting the y1 value with our y1 value of negative 4. And we're going to be substituting the x1 value with our x1 value of negative 2. And we're going to be substituting the slope with what we found, which is positive 3. So I'm going to rewrite this as y minus parenthesis, and I'm going to put my y1 value, which is this negative 4 right here, in place of it. And then I'm going to go ahead and put equals m, which our m is 3. So I'm going to go ahead and write a 3 right there, just replacing the m with the number that it represents it. And then put my parenthesis, and then x minus my x1 value. And my x1 value from this ordered pair is -2. So I'm going to put a -2 in there. Now the reason I say this created a little extra work is because now we have a negative on the outside and a negative on the inside. And remember, a negative times a negative gives you a positive. So we do have to distribute this sign here to what's inside. So basically a sign change occurs. So instead of y minus -4, it becomes y plus 4. And that's equal to 3, our slope, times x. And now notice this x right here, right? Again, we have a negative sign on the outside and one on the inside. I have to distribute it. So a -1 times a -2 makes it a +2. So this becomes plus 2. So I'm going to go ahead and box it. And if the teacher said, I want this in point slope form, this is our final answer for point slope form. That's what it should look like. Substitute the numbers, substitute the slope, and go ahead and distribute any signs you need to distribute. And then stop there. And that's the answer. Now from this point, if they ask you to go ahead and say, well, from there we want you to turn it into slope-intercept form. Okay, well, we're going to continue using what we created here, but basically we're going to solve for y. And when I say solve for y, we're going to get y by itself isolated so that it looks like this. Y equals mx plus b. So I'm going to go ahead and rewrite our answer here because that's always how we start. So I have y plus 4 equals 3 times x plus 2. I just rewrote this point slope form equation down here. So I'm going to convert it now. I want to get y by itself. So to get it by itself, we are going to have to eventually move the 4 over. But before we do that, we always want to take care of parentheses first. And notice I have some parentheses here. So what I'm going to do is take my slope and I'm going to distribute it to the inside of the parentheses. In other words, this is like me saying 3 times x, which is just going to give me 3x. Then you're going to go ahead and multiply and distribute that 3 to the +2. So 3 times +2. And that's going to give you +6. And then we're just going to bring down the left side of the equation. So we'll bring this down, y plus 4. So we're almost done here. It's almost in slope-intercept form, where it looks like y equals mx plus b. But to get y by itself, we got to move this 4 over to the right. So I'm going to use inverse operations. Instead of adding 4, we do the opposite, which is subtracting 4. And we'll do that on both sides. Now I want you to notice that I did not subtract the 4 from the 3x. I'm simply subtracting it from this constant, which is +6. You cannot subtract terms that are not alike. So that's why we're just subtracting it from this other constant value. What I have left over is y is equal to 3x. That we just bring it down. And then 6 plus -4 is going to give me -2, +2. So I end up with y equals 3x plus 2. And now I have the equation in slope-intercept form. So that's how you work through it. And that's a good reason to use point-slope form is if you have a point and the slope and you want to create a slope-intercept equation from it. But this shows you the entire process.